Hey everyone, welcome back to Gophercises. In exercise 19, I want to take a step back. We've done a lot of things with image transformation services and all sorts of other things like that. But what I'd really like to do in this one is just create something using mostly the standard library, although towards the end we'll be using SVG Go, which is a third-party package. But what I want to do in this one is I want to look at how to just create some images from the ground up. So there's a lot of reasons why you might want to do this. The really basic example is maybe you're building a site where you want to show somebody's usage of something every single month, and maybe you just want to generate some images for it. Now, I know there's a lot of JavaScript packages and all sorts of ways to produce graphs and those sort of things, so it's not that you necessarily need to do this by hand, but sometimes knowing how to make some really simple graphs by hand can be useful, or just knowing how to manipulate images by hand. So we're going to just sort of take a dive into the image package that's part of the standard library. And then once we've gotten a feel for that and we've seen a little bit of what it can do, what I want to do after that is to look at SVG Go, like I said. And I want to look at this because SVGs tend to be a lot better for the web and for the different types of stuff that we might be using it for. Specifically, SVGs are vectors, so they scale pretty much infinitely, and we can always just sort of or whenever we create them, we can work in things like shapes, things like rectangles and curves and arcs and circles and stuff like that. Rather than having to, actually go pixel by pixel or do other things like that, we've got a lot more flexibility in terms of just making it easier to introduce fonts and stuff like that. So the goal here is really just to get a rough introduction to these two packages, to learn how to create some images with them, and then to actually just make a couple bar graphs that we can then show off to people. So I've got the data here. It's just like a really simple version of data. I'm going to assume that we've already normalized the data in some sense. Specifically, I'm going to assume it's a number between 0 and 100, so it's kind of like a percentage integer. And we're going to use that to produce our bar graph. Now, you don't have to do this. The reason I'm doing it is because I find it easier to make my my bars or my bar chart or whatever whenever I know what the minimum and maximum bounds are ahead of time. You can do it the other way. You just have to calculate these things and do a little bit more. So it's kind of up to you. I personally am just going to go this way, and I can do the calculations before I pass my data in. Once we have some bar charts, I don't actually have an example here, sadly. It's basically just going to be a quick little image that has some different bars for each piece of data, and that's it in the first one. Then we're going to look at the draw package and understand how it, get a rough idea of how it works. Now, it's pretty powerful. There's a lot of things you can do with it that we're not going to cover. We're not going to cover a lot of the masking and stuff like that. But there are some articles. I'll mention them as we get going through all the exercises. There are some articles that show you how to use this that are on the Go blog. So you can definitely read those, get a better feel for it, and sort of experiment with it. And then finally, we're going to do SVG images with SVGO or SVG Go. And I will definitely say when we jump to this package, check this link out here at the bottom. I'm going to open it up and show you. So it's, it's looking really small there, but let me zoom out. Well, I'll just go around here. You'll see here when you're looking at this image, all of the different methods or functions that are available through the package are all given examples right here that are graphical. So this is really, really nice because you don't have to really look at the... Oh, sorry. No recordings early in the mornings because it's the only time I have time for them, and I'm a little bit tired still. But when you look at these, instead of just having to look at the docs, the docs are great for this package, but instead of just having to look at them, this is one of those cases where a picture is worth so much more. So you can look at all of these and see visual examples of what all the arguments are, how they're used, what the result will be. So this is like a single page image that pretty much defines the entire package, and it's just fantastic at actually just getting a quick overview of what you can do with it. So we're going to basically be doing, taking this package, and we're going to use it to create a little bit nicer version of our bar graphs. And then finally at the very end, I'm going to show you just a couple different, or at least one way to try to convert your SVG into a PNG in case you needed to. And we'll see probably in the next exercise where that's useful. Specifically, the next exercise is meant to be PDF manipulation, and what I'm thinking about doing is doing an invoice where it also shows some usage graph or something. And if I do that usage graph, embedding an SVG into that PDF it's possible, but the packages that are out there for Go and PDFs aren't that great with SVGs right now, but they can work with PNGs and stuff like that pretty easily. So that's one of the reasons why you might want to take an SVG and convert it into some other format, is to guarantee that you're going to sort of so that you can make it work with some other tools or whatever things you're using. So that's it. I know this is a kind of vague exercise, but really the goal is just to explore different ways to make images and just to have a little fun building whatever image you find interesting or entertaining. If you look through the SVG Go, there's also a lot of really cool examples, if I recall correctly. Maybe they're not here. I know there's a lot of cool examples here, but on top of that, I'm trying to look for it. I know Anthony Starks, the creator of this, has he's given a talk. I think he's giving another one at Gophercon this year. That basically goes over all the different things you can build with this, and he shows a bunch of examples of really cool things he's built with SVGs and repeating patterns and stuff like that. So there's definitely a ton you can do with this package, and getting familiar with how to build stuff with it can be really cool, because programmatically we can generate some really cool patterns that by hand would be kind of tedious to do. Okay, so let's go ahead and jump into using the image package first. Okay, so we're going to start by creating a Go file and then just figuring out how to create an image. And then once we've got our image going, we're going to go ahead and look at how to set pixels, and then we're going to use that to define some of the image. So this first version is kind of going to be a pixel by pixel building of our image. We're going to code main.go, and I'm going to need a func main. And then I'm going to go to the image package in the standard docs. And you'll see here that they import things like the PNG package at times to get the side effects of being able to decode them. Whenever we export things, so we're going to be taking images and saving them as a PNG, you end up using this package. So it actually doesn't matter that we're not you don't have to worry about the empty import here. So let's see. I don't want to do whatever that example is. All right, so I want to create an image, but I don't really know how. So looking at here, there's this image type, and you can see here that it's an interface. It's got something like a color model, bounds, which is a rectangle, and some at method, which will return the color of a pixel to a certain spot. So seeing this doesn't help me a ton, because I don't really know what implements this interface. So this is actually one of those cases where I'm going to go to GitHub Golang. This is one of those cases where seeing what actually implements an interface can sometimes be helpful. And it's not super common for me to run into that, but I'm going to go here to the source directory. I'm going to go to image, and I don't think I have. Let me go to source graph. And search public code. And I'm looking for image.go. All right, so I think this is the right file. I'm just gonna go ahead and see if I can find it on source graph or anything. I usually have the plugin installed. I don't really know. Well, this is frustrating. Let me go ahead and see if I can install the plugin real quick. I just want the source graph plugin for Chrome. Source graph, Chrome. So the reason this plugin is very nice is basically it's going to add some links to GitHub that are going to be really nice. There are other ways to get this sort of information, but a lot of times it'll depend on what tools you're using and how they're integrated. So that's why I'm trying to not do that. So now that I've installed this plugin and I've come back here and I'm at the image type here, you'll see that whenever I hover over things, the source graph plugin for Chrome is actually showing me a lot more. It's giving me this little pop-up. So I can click it and I can actually see things like find references, or I can come here and find implementations. So this is what I really wanted. I'm on this. I'm going to zoom in a little bit. I'm on the source graph page and I clicked the image type and then I clicked find implementations. And you'll see down below, it's showing me all of these different things that implement that interface. So this is really handy whenever you want to just see, what implements this interface. And specifically, I'm just looking for a way to create an image. So I'm just like, what can I do to get an image? Well, it looks like if we look at all of these different types, it almost looks like every type inside the image package is going to be implementing this. Not everyone, but a good chunk of them. So I'm pretty sure we can actually just use almost any of these that we want to use. So what I'm going to do is go to RGBA. So RGBA, type RGBA. And it looks like RGB is an in-memory image whose @method returns color to RGBA values. So that seems pretty reasonable. RGBA is red, green, blue, alpha, I believe. And basically it's just red, green, and blue is what you're used to with the web. The alpha is just the opacity of it. So knowing that, we can create new RGBA, pass in a rectangle. Well, what's a rectangle? A rectangle is a min and max point. And a point is going to be an X and Y coordinate. So that seems simple enough. Looks like there's also this rect function where you pass an x, y, x0, x, y0, x1, y1. It gives us a rectangle. So that'll be a little bit easier to use. So let's go to our code and let's do r is going to be image.rect, 0, 0 for the top left. That's the x and y. And then our x1 is going to be the width. So let's say we want this to be 500 pixels wide. And let's say we want it to be 150 pixels tall. Then we're going to be image is going to be image.rgba. I think it's new RGBA. And we pass in our rectangle. And then we need to decode this. Okay, so we want to decode this and write something with it. So I'm actually going to do the image PNG package. And there's different ones here. I know that all of these exist because I've used them before. And they mention at the top of the docs. But the package PNG implements a PNG image decoder encoder. And what I'm really looking for is, where are we at? Basically this encode. So it writes an image M to W in PNG format. So it looks like this is just a quick and easy way to write an image. And if we see here, this actually gives us a full example of actually doing something with an image. So we can look at this example in a second. But I'm just going to copy this code here at the bottom. So we create a file, image.png. If there's an error, I'm just going to change that to panic. It really doesn't make a difference which we use, but I've pretty consistently been using panic, I think, in these videos. So then we encode the image and write it into F, and we check for an error. If the error is not equal to nil, we panic with the error. And I'm going to actually just do defer f.close right here. And this is checking for all sorts of errors with regards to, it's checking for all sorts of errors with regards to like whether or not the file closes correctly, etc. That's a good thing to do, but it's not something I'm super worried about right now, so I'm just going to clean up or trim up the code. And then I'm going to go run this. And then I'm going to open image.png. And we'll see that we have what looks like nothing. What's going on here, huh? So we haven't written anything to the image. So I'm going to guess what's happening is that everything is just a completely opaque pixel. So we're going to go ahead and let's copy this code that they have here and see what it does. I'm guessing it does some sort of manipulation with the image. So it looks like it's setting the color. I just want RGBA for a lot of these. We have width and height. So we've got WH is going to be 150 for the width, 500 for the width and 150 for the height. I'll replace these two with W and H. Then I'm going to come down here, put H and W. So it looks like this is going over every single pixel and it's setting it. It looks like it's doing a gradient of, well, I'm not sure. It's bit shifting some stuff. And ending it within a 255. So let's just go ahead and run this and see what it's doing. Okay, so it's doing some like mini gradients here. And this is just sort of a byproduct of the math they're doing here. But you can see here how they created this image by going image or pixel by pixel and just setting it as a different color. And this is what I kind of meant earlier whenever I said whenever you are programmatically creating images, you can create things like this that might be a little bit weird to make with, by hand, but you can actually do pretty cool things like this with code. Okay, so we've got this image up and running. We've got some pixels there. Let's do one more thing. Let's comment this part out. Let's go ahead and try to create some graphs. So I know I started with some data like this is what I said we had. So let's just say that we want to create some bar charts. And I'm actually, well, first actually let me change that. Let's first go over the entire image. Let's do for y is going to be 0, y is less than height, y plus plus. For x is 0, x is less than the width, x plus plus. Then we're going to say image.set xy color.rgba, and we're just going to do, we're going to set everything to white. And then we're going to go over our data. And what I want to do is I want to put some sort of, bars. So we got to sort of think about what does the math for that look like. Well, we've got 4 data points, and they're going to be spread over 150 pixels. So we could actually change the width up here, like if we knew how many data points we had, but I'm going to let it be for now. Actually, I take that back. Let's make the image 220 pixels wide. That's actually not right. Let's make it 4 times 60 plus 10. So that should give us a little bit. So what I'm doing here, 4 times 60 plus 10, is, let me make this clearer. It's going to be data time, or length of data times 60 plus 10. So what I'm doing here is I'm assuming a 10 pace padding, or 10 pixels of padding, 50 pixels for the bar graph thingy, whatever bar we're going to put, 10 pixels of padding. So we've got 10 pixels of padding, 50 for the thing. So that's each individual data point's going to need that. We're going to stack them side by side. But then at the very end, I want to add 10 more pixels of padding to keep it uniform. So that's how we have the length of data times 60. And then this right here, 10 is the very last set of padding. And what we're going to do here is we're going to say for I, comma, data, let's do DP for data point. In the range of data, I'm going to say that we're going to say for x is I times 60 plus 10. Yeah, that's right. Actually, that's wrong. So I times, so if it's 0, we want it to go over 10 pixels. So we definitely need, a 10 there somehow. If it is 1, we need to have 10 plus 50 plus 10 more. So that's going to be I times 60 plus 10. So we had it right originally. Then we're going to say x is less than I times 60 plus 60. So we could just say I plus 1 times 60. And basically what I'm saying here is that if i's, say we start at pixel 10, so we add 60 here for the second one so that we stop at pixel 60. So between 10 and 60 would be our 50 pixels wide. And then we're going to do x plus plus. So basically right now we're defining the x range that we want to fill for our bar graph. Now we need the height. So we have our image is 500 pixels tall. That's fairly tall. So we're going to assume that, what we could do is just make the image 100. Just make it 100 pixels tall. And now we're just going to fill the entire image. So let's just start with that because it's simpler, I think. So we're going to say for y is going to be 100 because we want to start at the bottom. So for y is 100, y is greater than or equal to, or do we want greater than? That's the real question. We'll say greater than equal to, and this is where we need to figure out our data point. So I'm going to start at the bottom because, bars are typically growing upwards, they're not growing downwards, and our bottom is going to be 100. And then as we go up, we want it to be whatever the length of the data point is. So we're going to say 100 minus data point. And we do 100 minus here because let's say we want 30, so we're only going to show 30 here. So our bottom's going to be at 100, our top should be at 70, and then there should be between 70 and 0 is all above this. So 100 minus data point will get us that 70. And then we'll do y minus minus. And then for each of these, we're going to say image.set x, y, color.rgba, and let's just set it to, I don't know, let's do a light bluish color. So we'll do like a 180, red, green, and then blue will be 250. Then we'll do 255 for the opacity. And that should create this rough bar graph for us. Now let's see if it actually works. All right, so we apparently did something wrong here. Oh, I set my width wrong, that's why. The width is supposed to be the length of this data stuff. And then the height's supposed to be 100. So I think now that we fixed that, let's see what that does. All right, let me bring this back on the screen. You can see here that we now have all of these bars showing up correctly. Now, obviously this is not an amazing looking graph, and I think that's fine, but it's definitely, drawing these bar charts the way we wanted, and they're using the data points, 10, 33, 73, 64. We could change these. We could make this one 100. And you'll see this one's a full, covering the full image. So I think that's a good stopping point. This obviously isn't the most amazing things in the world, but I just wanted you to get the idea that you can, as long as you do the math or figure out where you need things to be colored, you can, with this package, just go through and pixel by pixel create things. Now, yes, it's going to be tedious, and it's probably not what I'd recommend long term, but anytime you do need to make changes like that, that is a possibility. So it's cool to know that we have that custom control of manipulating every individual pixel. Okay, in the next video, we'll look at the draw package, which is gonna be a little bit different. It has a Golang article here that I'll cover. I'll click, at least show you whenever we get to the next video. But for now, let's just go ahead and I'm gonna go ahead and close this video up. But yeah, that should be it. So the next thing we're going to do is look at the image/draw package that I clicked here. If you click on this article, this is, it's older, but it's still, completely up to date. You're fine with reading it. Basically what this is going to talk about is how the draw package works. And if you want to sum it up, the easiest way to sum it is that the draw package will take a destination image, a source image, and you'll choose a rectangle of the same size on both of these, and you'll tell it where to put that rectangle on each of these like they're showing you here in the picture. And then it's going to take whatever's in here, and it's going to write it to here. Now, the caveat is that it also allows you to apply a mask. So you're seeing here they're using a gradient here to do the mask, so that whenever they write the image, you end up with something that's, it's got a gradient applied to it, so it's, fading out on the left side, and it's, more solid on the right side. Now, you don't have to use those things. You can see here they've got a destination source. The mask is completely white, and the result is just completely overwriting the destination. You can also see with things like this where they're using a white mask and they're taking this gopher and just writing it onto the image. So there's a lot of details, and there's a lot of things you can do with this, especially with the masks. Let me scroll down here and show you. Here they've got a circle where they're actually using the mask to only get a part of the image. You can also use things like letters to sort of just get the letter in a certain color. So there's all sorts of things you can do with this, and it's pretty powerful with a lot of it if you really want to dive into it. But I personally prefer dealing with like SVGs and things like that if I can, so I don't want to spend too much time here. What I'm actually going to do is just show you how to use this draw in order to create our bar graphs, so that we don't have to go pixel by pixel, we can just draw them real quick. Okay, so the first thing is we need something to draw with. So, in all these images, there's a destination where we're going to write to. Well, that's our image that we have open. But what is our source? Where are we drawing from? Well, if you look in the image package, there's something here called type uniform. And this is an infinite sized image of uniform color. So that sounds kind of weird at first. Why would you want an infinite sized image? But it's really awesome for this draw package because this uniform, basically it gives us a source that we can always pull from. It's going to be a solid color and it's going to be as big or as small as we need it to be. So what that really means is that we can basically just do something like, let's say blue is going to be image.new uniform, and the color is going to be this color here. No, not that color, this color. And then we'll say gray is going to be, let me grab this color, image.new uniform. And I'm going to make this a little bit more gray. So let's say we did 240s for all these. And I'm going to keep the opacity the same. All right, so now I'm going to go through here and we want to see, instead of this big for loop, can we just use this gray to draw over the entire thing? So we have draw.draw, and it's going to take a destination, which is our image, a rectangle, which is going to be, we have this rectangle up here, which actually will work fine. Because it's just the full size of our image, and right now we're just trying to set the whole thing to this gray background. The source is going to be this gray, SP image point. So image point, if I recall correctly, is image point, that should, SP is source point, I believe. I'm not sure how you set the destination point in this. Maybe you have to use draw mask, or maybe it's set by, oh, okay, I know what's happening. Whenever you create the rectangle, you're defining the image point because you're saying, top left corner is these two coordinates, the 0, 0, and the bottom right corner is these two coordinates. But that also defines the size of a rectangle. So instead of creating a whole new rectangle for this image point, so, instead of for this source image creating a whole new rectangle, what we end up doing is, let me zoom in a little bit. What we end up doing is just using the same rectangle, but we just tell it where to put the top left. So it'll take the width and the height that we gave it from this original rectangle, and it'll update it to make a new rectangle based on whatever starting point in the top left we give it. So that's what the source point is. And in this case, we can do image.point, and I think it's just 0, 0, because we're going top left corner. And then OP, that is op. Let me go ahead and look. So op is Porter-Duff composition or compositing operator. So we've got over as in over destination, and source, which is source and mask. I think this article, if I recall correctly, covers these two a little bit better. I feel like up here. For a fully opaque mask, this reduces the original Porter-Duff formula, destination equals source OP. All right, here we go. The over operator performs the natural layering of source image over the destination image. The change to the destination image is smaller, where the source after masking is more transparent. That is, has lower alpha. The source operator merely copies the source after masking with no regard for the destination image's original content. So if I'm reading this correctly, if you have some alpha on your source and you use over, the alpha will end up being, you'll see it here in the destination. It'll take that into consideration. So it won't be fully whatever color it was. And that's that RGBA, that last value, the fourth value. Source, on the other hand, is just going to take whatever the color of this pixel is, and it's going to replace this pixel in this destination image. So source is what we probably want here. So we'll do draw.source. And that should give us the whole background. So now that's this whole part here. So now we want to go ahead and create some of these data point things. So what we want to do is we want to figure out, top left and bottom right rectangles. Well, we know top left is going to be this I times 60 plus 10. So we'll say x0, comma y0 is going to be I times 60 plus 10, comma, and then our top left y is going to actually be this 100 minus dp. So there's our x0 and y0. So our x1, y1 are going to be, well, y is easy, it's 100. So now we just need to figure out the x. And the x is going to be this part here. And I'm going to subtract 1, I guess. I mean, whether or not you want to actually subtract this 1 pixel and everything's up to you. I don't remember if I need... I'm doing less than here, so I assume I want to. Okay, so now we have this. So we're going to say r is going to be image.new rect, or just rectangle. Or it's rect, okay. x0, y0, y0, x1, y1. And then let's just say bar, and then we want to write this onto our image. So we're going to go ahead and say draw.draw, with image being the source. Our bar is going to be a rectangle, and our source image is going to be this blue color we created up top. Source, or SP for the image point. I did 0, 0 before because on the uniform, this is just kind of where we're starting at. But realistically, this doesn't matter because uniform is an infinitely large, always the same color image. So we really could do anything we want here. But I'm just going to keep image point 0, 0. And then we want to do draw.source. And then we can get rid of all of this. So if we save that, and then we go run main.go, open image.png, and this appears to still be working. We can test this. I want to make sure we get a new color. So let me change this to 250 here, and we'll make this 180. So it should be a reddish color now. I just want you to, visibly see that it's a different image. And here we got this reddish color showing all of our bars, and it appears to be working fine. So that's, how the draw package works. I'm not going to go into, there's a draw mask function, which is, basically it's the same as draw, but it has a little bit more options. You'll see here, there's the mask, there's a mask point. I think those are the only two it adds. And that's this mask part here. If you just do draw, it assumes the mask is just meant to be an empty mask, like you're not actually applying anything. So it just assumes that it's like this mask here where it's all white and you're just keeping everything. I think that's what we're going to want for now. But if you want to mess around with the mask stuff, definitely give it a shot. We could even... Actually, let's go ahead and try that. Where is... This is what I want. So I'm going to go up here, and I'm going to say, or actually I'm going to do it right here. So remember that image we created earlier with the, gradients going diagonally. I'm going to create that and use it as my mask just to see what sort of result we get. So we have H here for height, W here for width, and you need to make sure we set this as mask.set. All right, so we've got all that. I'm actually going to do draw mask. And this adds the two arguments here. So we've got the mask, and then we've got a mask point, I think. And our mask point is again going to just be, let's use x0, y0. So that way it's going to get whatever gradient or whatever values are on the mask at the same exact spot. That's what it's going to use for our mask. So now let's go ahead and run this, and let's see what we get. Okay, so this doesn't seem to be doing much. My guess is that I'm not using the mask very effectively or usefully here. So what I'm actually going to do is, well, I guess we're just going to get rid of the mask part. I want to use the mask as the draw part. Blues declared not used. Yes, that is true. Okay, so now we've got these crazy bars. I was hoping I could get them to do more of a basically have the blue sort of a fading type thing, but I need to go look at a little bit more in how the mask stuff works because I honestly have not used it like at all. And let's see. I don't want the drawer, I want draw mask. Yeah, see, I'm not entirely sure how the mask is supposed to work in the sense of, how it decides. It looks, all the examples are just black and white, so maybe I just need to kind of stick with a black and white point. I'm not really sure. I could also just set them all as RGBAs. So we could do something like blue and point image dot point. This is probably a waste of time, but that's okay. What am I messing up? Undefined blue. Because it's up here. Let me go ahead and bring it back down here. I'll just define it when I'm using it here. And it's not even blue anymore. I'm not sure why I'm calling it blue. Let's name this red. What are our options for colors? Oh, our alpha is always 255. That's probably our issue. Let me go ahead and set the alpha here to be something that's actually changing. There we go. That's what I was hoping for. You'll see here how the mask ends up applying. It only uses the alpha from what I can tell, but it ends up applying that mask to give us this sort of like striped gradient look, but it's applying the red color with the mask. So that's what's going on here. And you could do all sorts of things with that. You could pretty easily just make a big gradient and have all of these, be gradient type bar charts or something like that. Probably not useful for a bar chart, but there's different options. You could even potentially apply some colors so that if something is getting, near the red as it gets higher, maybe you could do something like that. You could even, we could do something like this. So what is our height? So if we want to do a percentage, say the lower our y value is, the more, we want probably the opposite actually. The lower it is, the higher this alpha is. So we could say y divided by h is going to give us sort of a percentage, and we want to multiply that by h. So maybe we want to do something like this, assuming my math is not completely wrong. Oh, I wanted this, I think. Okay, so we've got the red at the bottom, and it looks like it's just the gray at the top. And I thought we were drawing a more gray background, but did we never do that? Oh, the background is gray. Okay, cool. So here you can see that we're drawing where the top doesn't get a whole lot applied to it. It's pretty opaque, and the bottom does. So what we're going to do real quickly is I'm going to reverse this. So I want, easiest way is just y minus h here. I thought. I'm sorry, I can't do math on screen like this. Basically, I want this to be something that's variable based on, I want the top to be like the darker color and the bottom the whole way down to be the lighter color. So what we could basically do is, actually, let me just go to the image package. There's got to be a gradient of some sort. Nope. Apparently, I'm completely wrong. I would have assumed there'd be something like that, but I guess not. So essentially what I want is something where the lower the y value is, the higher this gradient is going to be. And I'm not sure why I'm not just using this right here. So let's just say y divided by 100, or sorry, 100 minus y. So this will give us a percentage. So this whole thing divided by 100 is kind of what we want. So that's like our percentage, except we don't want that to be an integer like it is. And then we want to multiply this top part times 255. So let me just wrap this whole top part up here and just to make sure it works. All right, that's what I wanted. So the top is getting more of the gradient color, the red. The bottom is sticking with, you know, the whitish color, and it's just, that's because of the opacity. And what I'm going to do now is I'm actually going to come to all of these, and I'm going to first get a uniform. I've got red, and I'm going to go ahead and create another one. We'll call it gray. And up here, I'm going to make this BG. I'm going to make this a little bit lighter. I want these all to be 240. This is going to be BG. Okay, so first, I'm going to draw the gray on all these image points, and I don't need the mask. And then I'm going to paste this code again. I'm going to move this red up here, and I'm going to draw the red on the image point with the mask, the mask that I created right up here, this right here. And instead of draw source, I'm going to draw dot over. And where did I mess? Oh, this color's the same, that's why. I want this to be something like, let's say 175. Oh, we can do 180 everywhere. Okay, so you see how now that we've done this, images get a little bit redder as they get towards the top. So, you know, this doesn't have much red at all because the bar is, you know, it doesn't go high enough. But these images start to get more red, and this one goes all the way to the top of the red. So that's what I was trying to get to with this, you know, with this mask. So this mask is kind of a gradient that goes the whole way up, and we can very easily just set it to be something where like we only light up the stuff at the very top whenever we have an image, or, you know, whenever it's getting near the top of our graph. And I know it took forever to make that happen, but you see it a little bit more here. And you could even take this and do something a little bit different. You could say if y is greater than 50, maybe we'll say so I'm trying to think of how I want to do this. Basically, you could do something where if y is greater than 50, so if it's the bottom half here, we want to do mask.set and say the alpha is 0. So we're not going to use this at all. Otherwise, we could say if y is greater than, sorry, I wanted less than, yeah, we went greater than, okay, greater than 30. And these are all in the wrong order, so I'm going to have to reverse them. We'll paste this whole thing in here again, and we'll say in this case, alpha is, maybe it's going to be 100. And you'll notice that this RGB values don't actually matter, so I'm just letting them be. And then finally, I'm going to copy this, move it to the top. And then finally, we'll say if y is greater than 0. We'll say greater than or equal to 0. We want to set this to 255. Okay, so this is a little bit, we can do a switch, y, case, and I'm going to do right here, alpha 255, case y is greater than equal to 30, alpha is going to be 100, otherwise it's going to stay 0, and then down here I'm just going to go ahead and just take all this. And this will really clean this up a lot more. And, oh. I've been like, my brain's all over the place today. I don't think I did this right. So y is greater than equal to 0. Say y comma alpha equals y and alpha. So we're getting 255 for all of these, it looks like. Oh, because this is always true. That's right. What I wanted was if y is less than 30. And I wanted if y is less than maybe 50. Otherwise, the alpha stays 0. All right, there we go. That was a really slow way of getting to where I wanted to be, but so you can see here that you can start to add things like little notifications when you're getting near the top. Say, you know, it's really red up here, and this is a really ugly image, but you can see the idea of what I'm trying to say here. When we create a mask for the different alphas, and then we apply something like this red color, we can really start to, you know, show people that they're getting near this bad usage area or something like that. So that's it for the draw. I feel like we wasted way too much time here, but hopefully it was helpful to see how draw mask and draw both work and to actually see a mask being used. All right, in the next video, we're going to go ahead and look at SVG Go because I think that's a much more enjoyable package and you can do a lot of really cool things with it. Okay, so we've seen how to use the image package. What I want to do now is look at how to use SVGs. And we're going to be using this SVG Go package. It's linked in the exercise README. If you just want to find it, it's github.com/ajstarks/svgo. And then inside of here, there's this svgdef.png. Definitely check this out. This is an awesome way to sort of learn the package because every single function that's exported, it shows you an example of it, and you can very quickly understand how it works, what it does, you know, without any confusion or experimentation necessary. This is actually something I love compared to a lot of other visual packages and things like that. In the next exercise, we do some PDF stuff, and I kind of wish they had something like this for it, but I haven't seen anything similar. So once we're here, we're going to go ahead and grab this. So get these two lines and run them. I'll warn you that whenever you run this, there's a very good chance you're going to get some message that pops up that says something along the lines of, you know, you don't have some specific package or something. If so, you probably just need to go get that package as well. It'll give you like a name like this that's pretty easy to go get. Hopefully if Vigo or whatever ends up coming out will help with some of this with dependency management stuff. But for now, I don't know that this actually uses any sort of dependency management. I didn't dig too much to see. And I've got it working, so I'm not super worried about it. Okay, so once we get this installed, there's a couple different ways you can go about doing this. We can just write the code ourselves, or before I do that, I just want to show you SVG Play. So you can run SVG Play, and it'll open on your local computer at port 1999, a program that allows you to just write in some code here, hit Shift Enter, and it'll produce the output here on the right-hand side. So you'll see here that every time I hit Shift Enter, it's using time.random to produce the stars. So it's creating this differently every single time. And we can come through here and actually start to tweak a lot of this. You know, if we wanted to change the fill, we could make the color of the circle change a little bit. You know, we've got a lot of different options here for what we're doing. And this is just a cool way to visualize what you're building without having to, you know, constantly open up a file and close it. The downside is that you need to essentially just, well, basically the downside is this isn't your editor, so anything you're used to in a regular editor is not going to work. So I'm going to go ahead and just copy the code from this, though, and I'm going to come back here, and I'm going to keep data. I'm not going to keep most of the rest of this, though. Actually, I'll create the os.image. Maybe I won't, actually. So this is going to write to os.standardout. I think I've got an extra curly brace here, but I'm not sure. Main's read. Oh, it's because I have a main up here. Okay. Let me grab these data points before I do this. And then I'm going to put the data points in here, and I'm just going to say underscore equals data so that I'm using it for now. All right, so I've got this here. It's working. What I want to do next is just to make sure I have some way of running it. So I'm going to go run main.go, and you're going to see here this is going to spit out everything right into my terminal. So what you can do here is you can just put a little arrow and pipe it into a file. Or if you really want, back here, let me go ahead and just fix this. Not fix necessarily, but we could do something like os.open file, demo.svg, the flags. So we might want to go to Golang OS. And I want to go to examples, and I want open file, and I'm just going to grab all of this. Because these are, pretty standard permissions and stuff. So if error is not equal to nil, panic, error. Then I'm going to defer f.close. And then I'm going to take all of this, and I'm going to paste it up top. Move this data down here, down there. And then instead of doing os.standardout, I'm going to do f is where I'm writing to. Just comment out that data for now. Okay, so this should write to demo.svg now, so I don't need to pipe it. Piping it is really nice whenever you kind of know what you're doing with it and you're used to the terminal, but I'm opting to create the file in Go just because I'm guessing some people watching will have some troubles with it depending on their operating system or where they're running and stuff, so this might just be easier. And then we can do open demo.svg. This is not what I wanted to open this in. This is a little annoying. Yeah, so my Inkscape, I like broke the build at one point, screwing around with something. And I haven't fixed it yet. So let me just do this. Open the current directory. And then let me say demo.svg open with, let's say Chrome. Okay, so that's working. So now what I'm going to do is I'm going to say open with always open with. There we go. Now I'm going to grab a new window. And I'm just going to shrink it a little bit. All right, so now if I do open demo.svg, it should just open right here. Nice, so we've got it. All right, so we've got that all working. What I want to do now is I want to try to create that bar chart we had, but a little bit better version of it. So we'll start with just the data, and then we'll come back and we'll start modifying our code to support a little bit more. So we've got some random data here. Let's just say we're going to go ahead and just assume this is right. Before we did our width is length of data times 60 plus 10. So that's with all the padding we want to use. The height is going to be, for now we're going to say 100, but eventually it's going to change. And I'm going to delete those two lines. And then what we're going to do is say for I, val, and the range of data. I don't know if you can hear that, but there's a kid crying in the background. Apparently somebody is upset. So what we're going to do here is we're going to say we need to figure out the top left corner of whatever rectangle we're going to write. I'm pretty sure it's the top left corner. So what I want to do is I want to say, look here, rectangle looks like you define an XY, and then you define a width and a height. And then you have some style stuff at the end. So I'm just going to try this. Canvas.rect. Let's just say 0, 0. The width will be 50, and the height will be val. And then that's clearly not going to work, so I'm going to have to say I times 60 plus 10. I think that's what we were using before. And then we need some styling. That's the last part? Yes, it's styling. So I'm going to try fill, RGB, 77, 200, 232, the same color we have down below. Then I'll come down here. I'm just going to get rid of all this because I don't need it. So I'm going to go run main.go and open demo. Oh, I'm missing the height. So the height is going to be the val. It's probably complaining because width and height aren't used. Oh. So I need to call canvas.start. And if I recall correctly, let me get the doc. So I'm going to grab this github.com flash. I'm going to go doc.org/that path. And this, you'll see all the examples start with start. I believe it just initializes your SVG and says what the size is going to be. So start begins the SVG document with the width and height. Other attributes may be optionally added, for example, view box or additional namespaces. Okay, so I'm not going to get too worried. I'm just going to start it up with the width and height. Huh. Extra content at the end of the document. It's a little weird, but might mean we have something going wrong with our SVG of some sort, but I'm not really sure what it's complaining about as far as extra content goes. Line 10, column 11. I don't know where that came from. Oh, we didn't. So the way we open the file, it looks like we didn't clear out the entire file. So we just like wrote over top of a few lines and then we didn't do anything else. And I might have made that mistake on some other things. But let's see here. So we've got create. Maybe we want read write only. I don't remember. Let's see what happens if we just do create. Nope. Okay. So one of the things we might want to do here is just sort of say if the file exists, we need to clear it out. So clear file Golang. This isn't actually something I expected to need to do, but I know some ways to do this. I just don't know if there's a quick and easy way to do it. I'm just going to go ahead and just do something like this. So that's not what I want. I want this. So this is one of the reasons why something like os.standard out is simpler. Sorry. So basically what I'd need to do is I need to either delete all the stuff in the file. I need to put an end of file marker at the end of it whenever I have this stuff. And I could do that. Or I could even do like os.remove to delete the file if it exists and then just recreate a new one to start with. There's a couple different ways I could fix this problem, but I think it's going to be easier if I just write to standard out. And now whenever I run, I'm going to say go run main.go, demo.svg, and open it. Apparently I didn't want to open it. Not sure why it's being weird, but that's okay. All right, so I'm going to go ahead and just keep that. I'm going to get rid of this and open part because I don't need it anymore. All right, so when we look at this, you'll see that these are not what we expected. They're going down. And I mean, that's what the doc said. I just wasn't thinking about it. So we want our y's, when we create this, we need our y's to take that into account. We can't start up here at 0. So we need this to be something like height minus val. Now if we refresh, you'll see that this is actually showing up correctly. And then, yeah, this should be fine. So we've got this whole thing, it's working, but it's not very pretty. We might want to make these a little bit nicer. So a couple things we're going to do is we're going to add some labels to our data. And then we're going to maybe add a line that's like, if you go above this point, we're getting into kind of sensitive data. Or no, maybe not sensitive, but like you're getting above a threshold. Maybe you should start thinking about your usage for whatever this is. So we're going to start with the struct up here. And just so you know, going into this, I have not exactly practiced this exercise, which is why you're seeing a couple random bugs pop up. I'm just sort of doing it on the fly. So let's say that we're going to let's pretend like this is going to be your electric bill. So we might have usage, which is an integer of some sort. And then we have a month, which is a string. And then I'm not going to worry about any other information right now. So we might say that the month is going to be January and your usage is, say, 171. I don't know what unit we're doing here, kilowatts or something like that. But I'm just going to go ahead and just copy a bunch of these. So we got January, February, March, April, May, June, July, and then we'll say we stop at August. Maybe we're not done with the whole year. So now for values, at least where I live, January, February is oftentimes a little bit colder, so let's maybe it goes to 180. March, it's probably getting a little bit warmer, so we'll drop down to maybe 100. April, maybe we're still getting warmer, so we can come down to like 87. In May, maybe we're coming to 60. Let's do 66. And then maybe here's where we start to come back up, so we get to 55. All right, so we've got all these different things. Our width is dynamic, but our height isn't. So what I'm going to actually do is write a little function here that just helps us. Well, I can just do it in line. There's no reason not to, I guess. So height's going to be a minimum of let's just say height 0 for each value in the range of, or let's say each item in the range of data. If data.usage is greater than height, height is going to be data.usage. I don't want these are item.usage, sorry. Okay, so we've got our height and it sets the max and we go through all this. Let's go ahead and just run it and see what we get. All right, height minus val. That's because val needs to be val.usage, and this is going to be val.usage. All right, now let's refresh. All right, so now we've got, our graph goes a little bit bigger. The downside to this right now, and it's not something I'm going to fix, is that our image just gets bigger the more usage they have. Our image just ends up getting taller. So long term, you'd probably want to normalize the data in some way. Maybe that your image is always going to be 400 pixels tall, and we normalize this data to sort of be a percentage where whatever the highest value is 100%, and everything else just gets based off of that. I'm not going to do that for now, just because it's not something I want to focus on just yet. But I would definitely suggest that because I know you can scale vectors, whatever size you want them. The problem is your graph is going to be, say you always have a fixed width of 400. Your graph's going to change in size every single time you render it based off of that. So, I guess I could show you that, but we could say max. Those two become max. And we could say height is going to be 300. And then we could say we're going to start with height, and then down here, we're going to say we want to get a percentage. So percent is going to be val.usage divided by max. So this will give us a rough percent. And then we want to multiply that percent by the height. So we'll do it this way. Then here, this percent is going to be height minus percent, and this is going to be percent. assuming I did that correct. Did I never? This is supposed to be 300. All right. See if this works. All right, so it appears to be working. Let me see what happens if I make this like 666. Bad choice. I'll go 665. And refresh. You know, our image stays the same, but you know, everything here changes based on, you know, those values. So I'm going to go ahead and actually leave it like this, just because I think, or I'm going to keep this new version because I actually think this is going to make for a more interesting problem that we're going to work on here. Okay, so we've got all of this. We've got the percentage for each one. What we want to do now is we want to make this a little bit nicer. We want to make that whole image a little bit better. So one of the ways we can do this is to put labels on all of these. And to do this, we need a little bit extra room in the height. So let's say we make it 400, or let me take that back. Let's say we keep it as 300, but we just say the bottom 50 pixels are going to be used for putting labels. So when we talk about height here, really what we mean is it's going to be height minus 250. And this is probably going to be something like height minus 250, or sorry, minus 50 for both of these. And then what we want to do is canvas.line. And we're going to say this is going to start at x0. The y is going to be height minus 50. So this is like all the way at the bottom, minus 50 pixels. You know, it's not quite the bottom, but it's 50 pixels from the bottom. X2 is going to be the width because we want this to go the whole way across. And Y2 is going to be the same, height minus 50. And then we're going to say options. I think there's a stroke width. I'm not sure. Let me see. SVG stroke width. Looks like there is. All right, so I can just do stroke width and then give it a number. Probably do like 2 pixels. I assume that'll work. All right, so let's run that, refresh. Well, I might have to put a color for the stroke. All right, so stroke. I don't know if it's stroke fill or if it's something else. I'm not intimately familiar with SVGs. So stroke color SVG. All right, so stroke, you just put a color. So we don't need stroke fill, it's just stroke. There we go. So now we got that black line on the bottom, and I could change this to be something like RGB. Maybe I don't want it to be quite be black. I want it like 100, 100, 100. Run that again, refresh. And it's a slightly, you know, more gray. Maybe I want this to be 150 across the board. All right, so we got a nice line at the bottom. And now we want to go through and we want to add some labels. So maybe underneath each of these bars, we need to put a label for what it is. So again, this is going to be very similar to this. In fact, we can actually do it inside of this because we've already got the I and val here. So maybe we want to do canvas dot, let's see. How do we add text? It looks like it's text, XY, string, and then styling. It's called text. The X is going to be I times 60 plus 10, the exact same text we had. Although we might want to figure out a way to center it or something like that here in a bit, but I'm just going to go ahead and just start in the top left corner and assume that it's left aligned. I think it is. The Y, we have height minus 50 is where that line is. So maybe we want height minus 40 so it's got a little bit of padding, or maybe like 40, 46, something like that. We'll see how that works. And this, the text is going to be val.month. And then this will do stroke black. We'll see how that works. Okay, so it's putting these here, but I can't tell if it looks like it might be center aligning the text. So align text SVG. So it looks like we got text anchor. All right. Vertical align text SVG. So we've got alignment baseline. I don't think that's what I want. Well, let's just go ahead and just fix this the simple way. Let's go like -22. Rerun it, refresh, and we've got these texts down here. Now, this text isn't very great looking, so maybe we want to go back and look at where was... Did we have something open? SVG play. Here we go. So I'm going to grab some of this and just slap it in here, see what we get. And this has a text anchor middle, which is going to change up our things a little bit, but that's okay. Ooh, that font size is way too big. So let's go 12 point. And it's white. We don't want white. We want RGB. Let's go 150, 150, 150. All right, so it's center aligned, which is not what we want. We could actually make that work though. If we look up here, whenever we do I times 60 plus 10, that's going to be the far left spot. Well, we know our bars are 50 wide, so all we have to do is add 25 to that. So this becomes 35, and this should be fine. All right, those are all center aligned. And maybe we don't want it quite so low, so we do or maybe we just make the font size a little bigger. And take this to -20. And then we run it and see what we get. Okay, that looks pretty decent. It's not amazing, but it's pretty decent. I'm going to bring this just a little bit closer, I think. And then I might... Oh, that's not what I want. I want the other direction. And then long term, I might want to, maybe get rid of some of the bottom of this image, but we've got this nice graph here. So the next thing I want to do is add a bar that sort of shows some threshold. So let's say our threshold is going to be anything over, let's say 120 is going to be considered, you're really high in usage. Maybe you should consider looking at ways to lower your utility bill. So I'm going to say threshold's 120, and we need to figure out where that threshold's going to be. So So once we're done with all that, actually, I'm going to go ahead and say thresh % is going to be something along the lines of the same percentage we did before. We're going to say threshold times height minus 50 divided by max. And then what we want to do is we're going to do canvas.line. X is 0. Y is going to be thresh. I think it's height minus thresh, actually. And then x2 is going to be width. And then our y2 is going to be the same one, so height minus thresh %. And let's say stroke is going to, and this is the styling string, so we're going to say stroke is going to be RGB. Maybe we want this to be red, so we'll say it's going to be like 250, 150, 150. So like a light reddish color. Maybe we want these to be a little bit more reddish like this. And then we'll say opacity is going to be 0.8. So something like that. And we'll say stroke width is going to be 2. And then maybe down here we want to make this, let's do 2. I think pixels will be fine. All right, so we've got a nice little line here now going across that shows you when you're in that threshold area. So maybe I want to make this a little bit more, a little bit more announced, a little bit darker. So we'll start with 255, 100, 100. And then what I'm going to do above this is I'm going to say canvas.rect. And we're going to draw a canvas above this that just sort of highlights that area with a really light red color. So we're going to go ahead and say the X is 0, the Y is going to be 0, the width is going to be the width of the whole screen, and then the height is going to be height minus threshold %. And then our stroke is going to be, fill. So this is a rectangle. We want to fill it, not have a stroke. Or you can do the stroke, but that's like the outline of it. Fill is going to be RGB, 255. We'll do 100, 100, same things. But then we'll do opacity is going to be 0.3 maybe. All right, so let's run this. There we go. So now you can see that we've got this clearly red area. You know, it's marking it so that you know that this is kind of, you're in the red zone. We're going through with all this. I want to test it and make sure it works. So let's say we change, you know, right now 180 is our max value and our threshold is right around there. Let's go ahead and see what happens if we, let me move this a little bit for you. Just go like this. All right, so if we change this to be 332, and then we run it, refresh. All right, you'll see that this line got moved down, but everything is still above it, exactly sort of where it was, but we're using that percentage and making sure this image is a constant size. And then as we go through here, we can sort of just toy with this and figure out what values we like, but you can see that you can create some really cool, simple graphs this way, and other, you know, just image vectors or image vectors that are useful. So, you know, that's pretty much it for the SVG part. If you want, you can always toy with, you know, doing a little bit more than this. For instance, with the image package that we looked at originally, you could look at how to write with fonts. You could also look at how to use the mask there to maybe do watermarks, especially if you have some fonts and things like that to work from. You know, there's all sorts of cool things you can do with that. But yeah, I think for now, I think this is a good stopping point. This graph is, you know, it's going to give us a good thing to work from with. I'm going to make this back to 32, and I'm going to say maybe the threshold is actually 160. Run it. Now that we've got this nice little graph, I think in the next exercise when we start to create, you know, different types of PDFs and things like that, we can maybe use something like this inside of our PDF. The only thing I'll mention is that maybe you want to August, September, October, November, December. So maybe you wanted to add more months than what we have. So one way to do that is just add zeros. So you'll see here that we're going to get this. We got zeros here. Another thing is maybe we want to convert this to a PNG for some reason or some other format. I can't say for sure which tool you should use. Some people recommend Inkscape. I broke my current version of it. I need to go fix it, reinstall it at some point. But in addition to that, there's also a tool called RSVG Convert. And you'll see here, it's on Linux, it's on Mac. I'm pretty sure you can get it for Windows too. But you can basically just say in.svg out.png like this, and then you pass in some options. So you can say like a width. So for instance, we could do something along the lines of RSVG convert. Width is going to be, maybe our whole page is going to be 1,000 pixels. And then we can say demo is the input, demo.png is the output. Open up that demo.png. And this gives us a nice little graph to work from. You'll notice that the whole thing isn't white because I don't think we ever set our canvas color or anything like that. So maybe we need to look at how to do that before I close up this video. And you could probably just do that by drawing a big rectangle on it, but I'm gonna guess there's another way to do it too. Oh, you just go ahead and write a rectangle the whole size. That looks like what they're doing. So you could do canvas rect, and then we'll say fill white. So we can do something like go run this and RSVG convert W1000 demo.svg demo.png. And we'll open demo. And now this seems to have that white background that we expected. So if I make this bigger, it'll make it more obvious that there's gray around the outside. But there we go. We have a nice little image we've created. It's looking pretty decent. And now we could start embedding this into things like PDFs. If we have a dashboard, we could always just build these things dynamically and just, you can actually take SVGs and just slap them directly into the web page. They'll render them completely fine. That's why we're rendering this in Chrome. So they're really awesome for just displaying and things like that. Even if you were building, say, like a dashboard for your internal metrics, these types of things can be really cool because you can just make visualizations for your data and just quickly make a custom one without having to worry too much about building a ton of stuff. Okay, hope this was a useful and fun exercise for you.